The HS truck loading shows a variable spacing of two rear axles from 15 to 13 feet. The correct spacing is the length that produces the maximum effect for stresses in simple span bridges. The spacing is the minimum value 14 feet. However, for continuous spans, a spacing greater than 14 feet may be produced. The maximum stresses. The influence diagram indicates the proper spacing of the axles, which result in maximum stresses. In addition to the truck loading, the specification contains equivalent loading that is shown in the figure 11.3 to be used in place of the truck loading when they produce a greater stress than the truck. Prior to the 1944 specifications, the design live load consisted of the basic. The design live load consisted of the basic H truck preceded and followed by a train of trucks weighing 3/4 as much as the basic truck. In 1944, the HS truck was developed and the equivalent lane loading took place of the train of trucks. Presently, only one truck is to be used per lane per span. For longer spans, the equivalent loading produces greater stresses than the single truck. The span length at which the loading changes for shear calculation is different than that for moment calculations. The concentrated load used in the equivalent lane loading is different for moment that for shear calculation. Only one concentrated load is used. Inner loads are used for the determination of the negative moment. So from now we are going to study about dead loads. Here are the some materials and the dead load of that material.